Representing linear non-proportional relationships. How can you use tables, graphs, and equations to represent linear non-proportional relationships? Well, we're going to use our friend the whale that we used before so that we can explain and remind ourselves what a proportional relationship is, and then we'll kind of tweak it to get the non-proportional. So we've already talked about this, where in a proportion we have a whale that can eat an average of 2 tons of plankton every day. We made a table, so like on 0 days, 0 tons of plankton. On 1 day, 2 tons of plankton. 2 days, 4 tons of plankton. We took these points and we made a graph over here. So we had points 0, 0, 1, 2, 2, 4, 3, 6, and so on, and we were able to make a graph. And we were also able to make an equation where this represented the slope of the line, and able to make an equation that explained all of the relationships. Now let's take this a step further, and we're going to look at tables, equations, and graphs, and being able to tell the difference between when something's proportional and when something's not proportional. So let's start with the graph. What we're going to do is take a look at rate of change. In other words, we're going to take a look at slope. And we'll start with line A. And when we're looking at line A, we're going to pick 2 points. Now I'm going to pick these 2 points here, and we can see that this is going to be 2 over run, because we know that slope is rise divided by run. So if I was to write down what my answer then would be, it would be 2 divided by 1. Now I could have made a bigger triangle. 1, 2, 3, 4 boxes high and 2 boxes wide. And we know that 4 divided by 2 still does simplify down to 2 over 1. So it doesn't matter how big of the triangle that you made as long as you're going from point to point. Okay, so now let's take a look at line B. And let's see if we can come up with, again, the slope or the rate of change. So we'll find 2 points and make a triangle. And again, rise over run, 2 over 1. So we can see that the slopes are exactly the same. So what does that tell us? That tells us that these slopes, both of these lines are going to rise the same amount and run the same amount constantly. That means that these lines are parallel. They are never, ever, ever going to run into each other. But there is something different about them. One starts at 0, 0, the other starts at 0, 5. So because they have different starting points, they are a little bit different. And this is what makes it something different between being proportional and not proportional. It's that small of a difference. So rate of change is the same, but does not go through the origin. It's not proportional. So we've got a rate of change. It stays constant, but since it's not going through the origin, we're going to say it's not proportional. Okay, that's all you have to remember. So we can see it with a graph. It's pretty obvious when you're looking at a graph. All you have to do is find that where it's crossing, and you can see it's where it's crossing. That tells you if it's proportional or not. So now let's do it by table. Now again, here's table A, which represents, again, our friend the whale. We did this one already, but let's take a look at table B. Now table B, we're going to start, if it's 0, we know it's 5. And then we're going to go to 1, we're going to get 7. At 2, we're going to get 9. And at some point, you're going to realize, because we've already talked about the slope being by 2 over 1, that this is changing by 2. Okay, and again, how can we now, again, our thing at the beginning was, how can you tell by looking at a table? You know, we can tell by a graph, right? We can tell by its starting point. But how can you tell by looking at a table if it's proportional or not? Look for where x equals 0. If the y is 0, then it's proportional. If it's not, then it's not proportional. So we just kind of look for those numbers in our table so we can find if something is proportional or not proportional. Now let's take the next step and talk about an equation. Now, again, we have our graph, our table, and our equation, and we know that we have y equals 2x, and that 2 right there represents our slope. Well, we know line B has the same slope, so let's start out with y equals 2x. But they're not exactly the same, are they? These aren't the same lines. If they were the same lines, they'd be on top of each other. So we know that something has to happen. Well, more than likely, this 5 is going to have something to do with it. This positive 5 is going to have something to do. So let's take a look at what's going on with the table and our rule. Another word for equation is a rule of the function. So if we think about it that way, taking a 1 and putting it into this, 1 times 2 is 2. We can do the same thing for 2. Put 2 in there. 2 times 2 is 4. We see how it works. We've got to figure out what number we're going to have to put in here to figure this out. Well, the easy one is to grab a 0. If I put a 0 in here, 2 times 0 is 0, but what will give me to get to 5? I will need to add 5 more to get there. So let's test it and see if it works. If I put a 1 into this rule, 2 times 1 is 2, 2 plus 5 is 7. I can try it again with 2. 2 times 2 is 4, 4 plus 5 is 9. And we see that this rule is applying. I can put a 3 into there. 2 times 3 is 6, 6 plus 5 is 11. So this rule is working for us. So we can kind of spot that because of this something out here, that means that it's not going to be proportional. So if we're looking at an equation, if there's nothing there, and the reason there's nothing is because it's plus 0. And since we don't really talk about plus 0, we don't show it, because that really doesn't affect it. So, but when you see something like this, something out here, you know that it's not going through 0. This one's going through 5. We can use that same idea if I had a negative 1 out here, 2x minus 1, that's telling us that our graph is going through negative 1. Now, so to remember for us, if you cannot multiply the slope by x, just by x by itself to get there, that means that you have to add or subtract something to find the rule. And that means it's not proportional, okay? Because you've got to make that change. That's telling you it's not going to go through the origin. Now, there's different things that we know, that some examples of things that are proportional in real life and things that are not proportional. Some things that are proportional in real life are like buying clothes, going to the movies, or bus fare. All of these things, if you don't do them, if you don't buy clothes, if you don't go to the movies, if you don't ride the bus, you won't spend anything. So all of these will have a point of 0, 0 to start with, and it escalates from there. You'll start spending money or doing things as you go along. Same thing with some certain cell phone contracts. Now, things that are not proportional are maybe when you buy stuff. For example, let's say you were buying something online and they charged a $10 shipping fee. Well, you're going to pay $10 no matter what you buy. So, you know, that shipping on items is what's going to cost you. Maybe some cell phone contracts. Some cell phone contracts like, yeah, we'll charge you, you know, $20 a month, but it's $1 a minute. So that's changing a little bit. So that's not proportional. You've gone bowling before. You've had to buy shoes. You've had to spend $2 on those shoes. Well, before you even bowled a game, you haven't even bowled one game yet, which is changing, but you've already spent $2. So these are things that are not proportional. Now, there are two ways to look at graphs that are linear that we want to keep in mind. We have what we call concrete amounts and growth amounts. When we talk about concrete amounts, when we graph concrete amounts, we're going to see the graph be just dots, just like this. And the reason that is because these are whole numbers down here. And think about maybe ordering something online. You might order one item or two item or one bus ticket, two bus tickets, or one movie ticket, two movie tickets, three movie tickets. So those things are going to be dots. And we'll use the bowling right now in the game for shoes. So let's say it's saying, hey, it's $1 for shoes, and then it's $1 a game. So just to get one game, it's going to cost me $2. Two games is going to be $3. There's no half games. Since there's no half games, I'm not going to have anything in between there. A growth amount would show something more like, let's say I planted a tree, and I started the tree or plant at 1 foot. So this tree was 1 foot tall when I planted it, and that would be my growth start. And as time passed, it grew and grew and grew, and I'm going to get some fractional amounts in there. So that's more of a growth thing. So you've got to know what you're plotting, especially in a real world scenario. If it's not a real world scenario and you're just looking at an equation to graph, yeah, it's going to be a straight line. But we use these dots because sometimes it is a concrete amount that we're looking at. So hopefully this help explains what the difference is in looking at representations of linear and non-linear and what's proportional and not proportional.